Hello class, we are working out of your Algebra 2 book 8.2. You will need your book on page 338 to go through some of the examples in the pre-reading. If we look on page 338 in example 1, then we see that we are given a relation Q with some plotted points in a set. If you're asked to find the inverse of Q, then we are going to consider our math notation and what that looks like. Okay, so Q is equal to some set of given plotted points. You can look this over in your book. And you're going to be looking for the inverse, denoted with a -1 in the exponent. And that will be related to a set of plotted points. How do we get there? You're going to switch the x and y's. So we know we have a plotted point set for x and y, and that will go to y x in the inverse. So we're switching our domain and range is what we are doing. So look that example over. Also, the other thing to note is when you plot your points visually on the graph, as you see in example 1, that we have a dotted line at the origin. That is y equals x, and there is a reflection from the original Q to the inverse of Q. You should be able to fold a piece of paper across that dotted line, and your shape should match when you fold on the y equals x line denoted as you see in your book. Okay, so if you were to put the blue original function plotted points in the graph on one side and then find the inverse of that set of plotted points, if you fold that across that dotted line where we denote y equals x on the plane in the positive for that one, then it should overlap. So that's your goal when we're finding the inverse. Okay, so just a couple ideas to note in example 1 as you work through that idea on your own. Let's look at example 2 on page 339. Okay, so you're given a function of x, and it's equal to 2x plus 4. And we are finding the rule for the inverse of that function. So to do that, as we've already talked about, we're going to find the inverse by showing a reflection, and numerically we will switch the x and y variables. So if we rename f of x as y equals the 2x plus 4, because when we put in a value for x, it yields a y. So we're essentially renaming the function f of x as y for that math notation for our purposes today. Then we are going to look for f -1 of x, which is the inverse, and we have to consider where our x and y is in the original expression and switch them. Okay, so if we switch them, we're going to do x for y and y for x, and then solve for y to find the inverse. I'll let you do that work as you are looking in your book on page 339 in example 2 to solve for y and find the inverse. All right, the next example, it's example 3 on the next page. we are going to show that g of x is equal to 4x minus 1, and h of x is equal to x plus 1 over 4. We are working with these, and our purpose of our problem is to say, are these inverse functions? How do we get there? Okay, we need compositions of the functions to determine that. So we're going to show how the composition of G composition H of x is equal to x, and H composition G of x is equal to x also. If we can get those to match by comparing the inverses of those compositions of the functions, then indeed they are inverse functions. Okay, how do we do that? Let's look. So we're going to test G H of x first. So G times x plus 1 over 4, which we were given. So we've got G of H going on here so far. And then we're going to pop that H expression into our G expression. So let's look at this closely. We're going to go back to 4x minus 1. That H is the x. The function of H is our x in the G of x. So how do we do that? 4x minus 1. Okay. We're going to say 4 of x, which is x plus 1 over 4 here, minus 1. This is our h function that we were originally given. The whole h function is now our x in the g function. That's what's happening here. Okay, now we solve and we see what we come up with. So if we solve this, we have 4 over 4, that goes away. We have x plus 1 minus 1 left over, and all of that equals x. For the composition of G composition H. Let's test the opposite. We're going to do H composition G of x. Okay, and this little bitty circle is a composition notation. If I didn't already mention that. Alright, so if we do this, we're going to have H of G of x. And that's going to be H times 4x minus 1. We go up to the original G of x function expression we were given. That's 4x minus 1 here. That's what I'm using and where I'm getting that idea from. I basically say H times that whole G of x function. And if that's true, then I'm going to pop that G of x into the H function. So it's going to look like this. We're going to have 4x minus 1 plus 1 over 4. Okay, let's go back and look. See this right here? Okay, so this whole 4x minus 1 went in for x in this example. Then we still have plus 1 all over 4. That's where that came from. Now we solve. So on top we have 4x minus 1 plus 1. Okay, that goes away. And we have 4 divided by 4 here. So that goes away. What does all of that leave? Just x. So we have x here. We go back. Remember, we have x here. And if the yield is exactly the same in the composition tests, then they are indeed inverses. All right. On page 340, I would like for you to go over those examples on your own as well for examples 4 and 5. All right, and notice your math notation for inverse denoted with the -1 exponent. Notice your math notation for composition denoted with the little bitty circle. And that's what that means. So check it out in your pre-reading for 8.2. The examples are pretty quick to go over. Remember, to find inverses, we're essentially switching domain and range. So you're going to be looking at switching your x's and y's quite a lot. I hope this helps, and I'll see you soon.